Hey, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, we don't have a problem. Hey, today we want to talk about something called static electricity. As I know that this makes a marked change in what we've been learning about for a great amount of time. We've been talking about mechanics and kinematics and how things move, and now we're diving into electricity and magnetism. So in one of our first videos here, we want to talk about charged versus uncharged objects. Or basically the question I want to ask is, what causes something to acquire a charge? And it really comes down to this question: where does the charge come from? And the charge comes actually from an atom. So if you remember back probably to your chemistry class, you learned that an atom is consisted of protons and neutrons in the nucleus and electrons in shells. Now, when we talk about protons and neutrons and electrons, a proton we often write like this: P with a positive sign, meaning it has a positive charge, neutrons N0, and electrons E negative. And if you think about it, what holds charge of anything is protons, neutrons, and electrons. Neutrons have no charge, so when in our conversation about what causes things to charge, neutrons don't play a role. It's just the protons and electrons. Now, something also really important to understand, and again to sort of remember back from probably your chemistry class, is that the nucleus is tightly held. The protons and neutrons are in the nucleus, you can see in the image here. And therefore, you can't change the protons in an atom. But the electrons are loosely held in the shells on the electrons. And that causes, so the only thing you're allowed to change in an atom, unless you're doing a nuclear reaction, and we're not going to do any nuclear reactions, is to change or to move electrons. So when the electrons are moved, that's what causes charge. So when we talk about charge, we can have a positive charge or a negative charge. So let's take an example of an atom that contains positive and negative charge. So all atoms have positive and negative charge. Now in this case, again, this would be like two protons and two electrons, if you will, positive charge. This one would be what charge? This one would be neutrally charged because you have an equal number of positive and negative charges. And what about this one? I've got three positives and two negative, or more protons than electrons. So this would have I bet you can envision when they have a negative charge. Notice I have three positives and four negatives. So this would have a negative charge. Now I draw this. So one of the mistakes a lot of people make when they're doing this is to think that if something's negatively charged, it only contains negative charge. Or if it's positively charged, it only contains positive charge. But the reality is everything has positive and negative charge. My hand here, right here, has positive and negative charge. Always, if it's negatively charged, then it's negatively charged because there's more electrons than there are protons. Think of this: you rub your feet against the carpet, and then on a dry day, and then you touch the metal, and you get a spark, right? You get shocked, and that's because the charges are trying to equalize. So how does, these are our three examples, how does something get charged? And if it's neutral, it doesn't have a charge. But when we talk about a positive one, how does it become positive? What has to have happened? Remember back to our earlier conversation that said you can only move electrons. So if it has a positive charge, if you think about it, it's kind of weird. It's going to have lost electrons. So if it's got three protons and two electrons, then that what it means is it's lost electrons, because you can't move protons, you can only move electrons. Conversely, why does something have a negative charge? Because there are more electrons. And the symbol for an electron is this funny looking E negative. The last thing I want to talk about in this video is that I want us to talk about charge is actually a quantity. It's something that we measure. So let's copy down this table in your notebook. And I'm going to say that I have, in the first case, I have 9 electrons, and 10 protons. And actually, as I think about this, I forgot to tell you something. When we measure charge, we measure charge in something called a coulomb. And coulomb is spelled weird. It's Mr. Coulomb who kind of came up, C-O-U-L-O-M-B. And the charge of one electron the symbol for charge is Q, or Q of an electron is this number, 1.6 times 10 to the minus 19th coulomb. And the symbol for a coulomb is a capital C. And guess what the charge of a proton is? 1.6 times 10 to the minus 19th coulombs. They are the same. A proton and an electron have exactly the same charge. So if you look at this problem, I have one more proton than electrons. Make sense? One more proton. So what is the charge of this? Is you subtract the two. 10 minus 9 is 1. So this would be 1.6 times 10 to the minus 19th coulomb. Now, charge amount, actually I should say what type of charge? Is it positive or negative? Because there are more protons than electrons, this would have a positive charge. So it's fourth column, my bad. So this is not a column. All right, the next one, let's say I have 1,000 of these, and I have 998 of these. The difference is I've got more electrons than protons, and there's 2 extra electrons. So you would take 1.6 times 10 to the 19th times 2, and that's 3.2 times 10 to the minus 19th coulombs. And that, though, would have a negative charge because there's more electrons than protons. But let's do something that's a little bit more realistic. Let's say I have 8 times 10 to the 7th, that's a big number, of protons, and I have 7 times 10 to the 7th protons. So 8 is bigger than 7. So when you subtract 8 minus 7 times 10 to the 7th, you would take 1, 8 minus 7, times 10 to the 7th, times 1.6 times 10 to the minus 19th, and you get 1.6 times 10 to the minus 12th. Now I have more electrons than protons, so that means this is a negatively charged situation. Or let's even do something even crazier. Let's say I've got 8 times 10 to the 12th electrons and 4 times 10 to the 12th protons. Again, I would subtract the 2, so 8 minus 4 is 4, so 4 times 10 to the 12th are the same power, and then you would multiply that times 1.6 times 10 to the minus 19th, and you get 6.4 times 10 to the minus 7th coulombs. These are all coulombs. Now, which one do I have more of? I have more electrons than protons, so this also would be negative. And lastly, let's do this one. Let's say I have 2.2 times 10 to the 14th and 2.1 times 10 to the 14th. And when you subtract the difference, 2.2 minus 2.1, but they're to the power of 14. I said E14, that's the same thing. And then you multiply by 1.6 times 10 to the minus 19th, you get 2.1 times 10 to the minus 5th coulombs. Now I've got more, 2.2 is bigger than 2.1, so I've got more electrons than protons. Hold on, I didn't do this right. I actually had 3.5 times 10 to the 14th, and then I get 2.1, this is correct. And I have 3.5 is bigger than 2.2, they're both to the 14th power, and then this would be a net positive charge. So big summary on this video is how do you get charge? You get charge by having more protons or more electrons. Everything has both positive and negative charges. Here's an example of 2 and 2. But if I've got something that's 1, 2, 3, 4, 5, 6, I've got more negatives than positives. And it gets a charge because you have an imbalance of charge. And this table shows an imbalance of charges. And you can determine it's positive or negative depending on if you have more protons or more electrons. Houston, we don't have a problem. We'll see you in class.